Welcome to Project 3. I'd like to first direct your attention to page 125 of the textbook. You've already done this or you wouldn't be working on this project. At least that should be the way it is. If you haven't done the project work or the tutorial work and lessons through the chapters, I've said this a couple of times, I'm going to have to say it again, you've got to work your way through these chapters. You'll be totally lost if you don't. This is an online class. I don't mind helping you. And I'm putting these first projects out here for you to look at, but as we get on into this, you're going to be expected to do this stuff, have some responsibility for it yourself. I can't just do all the projects for you. You won't learn anything that way. Okay, so on page 125, they want you to type into your source code these three compiler switches: option explicit on, option infer off, and option strict on. Now, without that, which is what we were doing in projects or chapters 1 and 2, Visual Basic will let you get away with a lot of things that it's not supposed to. But like I said earlier in the last video, there's millions and perhaps billions of lines of VB code out there, so they couldn't change things so as to break what's already out there, because people still use that stuff. So they came up with these compiler switches. You don't have these options in other languages. It's automatically like that. Now, rather than type that in every time, I want to show you another way to get to it where you can do this globally as a project setting. So I've already got this project started. This is project 3. If you come over here to R Tools and go to Options and find Projects and Solutions right here, and then come down to VB Defaults. You can set these here and save it, and it should be that way in every project, so you don't have to type that in. All right, that's just, I've got mine set that way. So you should have option explicit on, option strict off. That should be on, excuse me. Sorry about that. Binary should be compare, option compare binary, and then option infer off. Okay, so it should be on, binary off. Now let's see what happens here. Let's see if it's going to impact what I've done. Yeah, okay. Now, here is my form. And this is your change maker project, which is it's exercise 8 on project 178. And just to look at this together, create an application. I just call mine project 3. You can do this if you want. I don't require you to name it the way they're doing it. I just do 3, 4, 5, 6. When I zip it up, it'll have that name on there. Change the forms file name to main form, and I'll show you that in a minute. That's standard stuff. Create an interface that allows the user to enter the number of pennies saved in a jar, which we have right here as a text box. See that? And the application should display the number of dollars, quarters, dimes, nickels, and pennies the user will receive when the pennies are cashed in at the bank. So I needed labels: dollars, quarters, dimes, nickels, and pennies. Now, I put mine in a container object, a group box. So if you pull up your toolbar and go to containers, it's right there. It just dresses it up and separates it out from this other stuff. That's typical Windows design. They didn't require you to do that. I just wanted to show it to you. Now here's another thing here. It says clear the calculated amounts when the change is made to the number of pennies entered by the user. That's a typical thing that you'll always do. If it's a calculated value based on some data the user has given you and they change something and walk off and come back. Now this is obviously a oversimplification, but it's very important that you remember this. If you change the number of pennies in this jar and you leave that calculated value sitting out there, that's wrong, because somebody else could look at it and say 66 pennies in the jar and I got $6 and blah, blah, blah. I mean, it's based on something that was put in there earlier. So if they make a change, then you need to wipe all this out. Okay. Now I've got a calculate button, a clear button, and an exit button. This is the only text box in the whole thing. So let's go to the code. Now I want to show you something. Well, let's start with this. In order to allow keystrokes when you're entering in data, the user's entering it in, you're going to have some sort of a mechanism to ignore it until it's calculated. Once the calculation is done, you can set that state to true, and if they do anything in the box to change that value, number of pennies in the jar, it automatically wipes everything else out and sets it back to false. So we start off with this as false. Now this is at the class level. So anywhere in here that I have code, I can see this. My code can see this. All right, so that just tracks the data changes. Now, one other thing I want to introduce you to are what are called regions. And when you get a lot of code in a project, it's helpful to put them in little sections and name it. Now, Windows already does that. If you see here, look at this. This is your code behind. This is all the code that wires these objects into my application. All right, so theirs is called region, Windows Form Designer Generated Code. And you can expand and collapse that stuff. So now I've created 3. And the way that works is you type pound region and then you put something in the string here. And you come down to the end of wherever you want that to be and you just type end region. All right. When you do that, you can collapse and expand it as well. That's just a way of doing it. I recommend you use this because if you collapse the stuff and you're looking for something, you can find it a lot easier that way. But there again, that's just something that I wanted to show you. So the exit button, I'm not going to deal with that because you already know how to do that. The clear button, it just basically sets all the .text properties to string empty. Now this is something you haven't seen before. What I'm doing here is I'm telling it to set the focus back into that text box so the user won't have to click on it. And that's just common courtesy, all right? If I calculate something, I want to make sure that they can, the focus is back in that text box where they can type in some more numbers or whatever. And I do that with the calculate functionality and the clear functionality. And I'll show you that in a minute. So I'm not going to do that. You did this in the last one. It's the same idea, except I'm setting the status here. See that? Okay, so let's go ahead and look at the button calc click event. This is what does the actual calculations. And we got to start off. Now what I've done here is I thought I had put one more comment up there. Variable declarations. Whoops. All right. So these are just comments that separate out the logic, okay? There I'm setting focus and there I'm setting this to true because once you get through calculating it, I need to make sure that if any changes are made down in here, and I'll show you when I set that up, that it is wiped out. And that's all it does. There are other ways to do it. It's not going to work the way they have it exactly in the lessons. So I went ahead and did this for you. It's a little bit, you can get in a lot of trouble trying to do this if you've never used it before. Okay, variable declarations. Well, what are we going to need? Well, let's talk about how the problem's going to be solved. You got a number of pennies in a jar. You need to be able to tell them the denominations that you're going to get back in the bank when you take it in there. And you always start with dollars, the highest, right? So you don't even have to convert it to pennies. It's already pennies. So you just grab that and stick it in the variable. And then you're going to divide the number of pennies by 100, and that will give you dollars. Then you got to take those dollars out of there, all right? You take them out, and then you have everything minus the dollars, the pennies minus the dollars. Now you're going to do the quarters. You take the quarters out. You're going to do the dimes. You take the dimes out. You're going to do the nickels. Take the nickels out, and then what's left in your variable are pennies already, and then you output your denominations. All right. Let's see what we need here. What do you think we need? Well, dollars, quarters, dimes, nickels, pennies, and any other variables I'm using here, do they need to be have a decimal component? No, it's not going to be $2.3. It's going to be $2 or $3. It's going to be 2 quarters or 4 quarters or 3 quarters. So integers is what you need. All right, so let's go ahead and declare a variable starting with the dim statement. Dollars as integer and initialize it to 0. All right. Now I'm going to have these for all of the various denominations. So I'm going to copy and paste this and just change it. It's a little quicker for me that way. Dollars, quarters, dimes, nickels, pennies, and then I want a working variable called temp. So I need to go in here and change this to quarters. Change this to dimes, nickels, pennies, and I'm going to call this temp. It's just a temporary variable for working variable. All right, so we'll save that. I mean, you may have to go back up here and add some, but I think this will do it. Grab the number of pennies in the jar. Well, the name of the text box is text pennies. What holds the data value that a user's typed into a text box? It's the text property, and it is of type string. Well, now that we've set all these different compiler switches, you're going to have to convert these to and from. All right, you can't just use a val function anymore. That's not going to cut it. All right, they say, and when you work through the chapter, you use try-parse methods like integer.try-parse, which is good, but I'm going to introduce you to something a little different. You should know both, especially when you go into other languages. So let's see what we got. I'm going to use one called convert, the convert method. All right, it does other things. It has its advantages. So you type in convert. There's the, whoa, what happened to my thing? Convert dot to int 32 tab, and that throws it in there. And then the name of the text box, text pennies, there it is. It's in the text property. Whoops. Right? And then that gives us the number of pennies into our temporary variable. Okay? That's all I've done. I'm just taking the text, which is of type string, whatever that number is that they type in for the number of pennies in the jar, converting it to an integer and assigning it into an integer. So this is either use try-parse or convert to. Both will work. You'll see later one may be better in different circumstances. Now we got to pull the dollars out. Well, how many pennies make $1? Well, I think you know the answer to that. This is just like counting back change if you think of it that way. It's no different. So dollars, assignment, temp. Now, in VB, there are different divisions. There's regular division with a decimal component and what we call integer division. The backslash is for integer division. Since we're working with the integers, we're going to do that. So I'm just going to calculate the dollars. If I divide the number of pennies by 100, it gives me the number of dollars, right? Okay. Now what do I got to do? According to my notes here, I've got to subtract the number of dollars from the temp change. Otherwise, I'll still have the same amount of money, and it's not going to work. It's just like if you're counting back. If there's 333 pennies, well, you know there's $3 in there. So you got to take the dollars out. What does that leave? 33 pennies. Okay, and then you work your way down. So we got to do that. And one way to do that is just to do this. Temp equals temp times, whoops, excuse me. Temp equals, yeah, it is temp, sorry. Temp minus dollars times 100. Now, if you're not familiar, or if you're not confident about the mathematical order of operations, you could have put this in parens, the dollars times 100. You want to do that first, but it's going to happen first anyway, because this is going to parse from left to right. It sees that multiplication, is going to do that, and then the subtraction. Okay, so now we got, we have our dollars. So now, and we've removed the dollars from the temp variable, which holds the pennies. And then we're going to calculate the quarters. So quarters, how many pennies in a quarter? 25. Okay. And then we're going to do this. We're going to subtract the quarters from the remaining pennies. Minus quarters times what? 25. Okay, so you see how that goes? All right. Let's see, keep going here. Calculate your dimes. Let's see, divided by 10, right? And then subtract the dimes. Now I've got too many spaces in here. I don't have to be this far apart. I just did this for readability. Temp equals temp. Whoops. Minus dimes times 10. Okay. See what's going on? calculate the dollars, subtract the dollars, calculate the quarters, subtract the quarters, calculate the dimes, subtract the dimes. And that way you'll get everything. It's just a lot easier this way if you start from dollars and work your way down. Because there'll be instances where you don't have nickels because you used a dime. You don't have two nickels, you have one dime. So that's just the way it tends to flow logically. Calculate the nickels. Nickels equals temp divided by what? 5 pennies in a nickel. Whoops, sorry. 5. Okay. And then when you subtract the nickels, minus nickels. This touchpad's driving me crazy. You know, I have a mouse here. Times 5. Man, that's not right. It should be minus. There we go. Save it. What remains are the pennies. So pennies, I mean, there's nothing, it's already in pennies. So if whatever's left, that's what the pennies are. So we don't need to do any calculation for that. Just that little assignment right there. Okay, let's see. Now we need to output our denominations. All right, now I'm going to put some breakpoints in here, and we're going to put some variables in the watch, because to be honest with you, the best way to do this is to have debug going on, because you're going to have some issues probably. All right, label dollars dot what? Text equals what? Format. Whoops, sorry. And then we're going to use dollars. All that does is convert it to a string. Now you can also do convert to string. You can do it like this, convert dot to string. I think I'm going to do that, so I'm doing it everywhere else. All right, so we got dollars, and I'm going to change the names here. Just make sure you're careful. Quarters, dimes, nickels, pennies. This would be quarters. Darn it. There. This would be quarters. And this will be dimes. This will be dimes. I'm just copying it because it's easier than typing it all in. This will be nickels. I call these with these names, and that's why I did it, because it's easier to do that way for me. Nickels. And then pennies. Whoops. Yeah. Pennies tab. And this would be pennies. See, IntelliSense sees all these things. All right, save it. And then all this does is just put the focus back in the text box and sets this global, or this class level flag, to true, which means, okay, now if there's any changes made at this point, we need to wipe all the calculated data out and start over, just like if they hit the clear button. And that's what that's doing. Okay, so let's go in here and set a breakpoint. See the little gray bar? That's where you set your breakpoint. Now, you can't add variables or objects to a watch unless you're in debug mode running. So I'm going to go ahead and press F5 and run it. See if we've got any errors. It didn't, amazingly. So let's start off with one of their values at the end. I've got some other ones we're going to try. Let's do 250 pennies. Well, that's an easy one, right? If you have 250 pennies, you've got $2 and 2 quarters, and everything else is 0, right? Because that's 250. So let's do 250. And let's hit calculate. Now what happens here is my execution of my program stops right here. It pauses. At this point, I can add all the, I'm going to go ahead and delete these and put it back in and show you how that's done. Clear all. Okay. At this point, one thing I can do is I can hover over stuff and see what's in there. But another thing to do, and this is really the way to go, is you right click on an object and go to add watch, and it puts it in there and puts a value in there. So I can do dollars, add watch. See, I'm showing up down here in my watch window. I can do quarters. I can do dimes. You'll see why I'm doing this in a minute. I can do nickels, and I can do pennies. Pennies. Okay, so I've got all this. The reason everything is 0 right now is because we just stopped right here. This assignment hasn't been made. So that's just pulling the number of pennies that the user typed into this text box. Well, why did I use .text? Because that's the property that holds that input, and it's of type string. Well, since we've set all these compiler options now, we're going to have to explicitly convert string into an integer before we can put it in here. Now, we haven't done try-catch blocks yet, so we're going to assume that all the input's correct. If it can't convert it, it will throw a number. An exception. If it can't convert to a number. Like ABC123, that's not going to convert in this language to anything. It's alphanumeric. So it takes this and converts it into an integer and then makes this assignment into temp. All right, now watch temp down here. See this? Watch. When I press F10, it should step through, and it did. Notice what's in there, 250. That's what the user typed in. Now let's see what we get with dollars. So it's F10. So now dollars is 2, right? All right, so the reason it's 2 is because we divided it by 100. So the number of pennies was 250, but divided by 100 leaves you 2, and that was assigned into dollars. See that right there? That's the beauty of all this. So if I press F10 again, it just keeps stepping on through. And let's see, temp. Hopefully, temp is being reduced. So temp is now at 50. We got $2.50 50 pennies. All right, now let's see what we do. What happens to quarters? Quarters is 2. Now look what happened to temp. It went to 0 because that's $2.50. There are no dimes, there are no nickels, and there are no pennies remaining. So we go in here and we put all this out. See what happens here. So I got $2, 2 quarters, 0 dimes, 0 nickels, 0 pennies. That is correct. Okay. Let me stop debugging. We're going to test this against some others too, because sometimes you get a rounding error in there. Stop debugging. Okay, so we got all that. Now, like I said, I wasn't going to do the clear, but I do have a button click event for clear, and it sets that status change back to false. And and you'll see why in a moment. That's the exit. Now we need a different event in order to be able to wipe out all this data if the user changes his initial input, his or her initial input. All right. And I'm going to show you, up to now, what we've done is when we wanted the default event for an object, you just double click on it. It puts you in code view and puts that event handler in there. But I want something different here. I want to be able to see when the user presses a key. But that tells me something's about to change. But I don't want that to happen when I'm putting data in there. Now, that's the reason for the status flag. Because if I just put it in there, every time they press a key or every time I add something in there, it's going to just not do anything because it's going to fire every time. So that's what the status change does. All right, now notice over here under properties. See the little lightning bolt? That is your event. That you put events in that are not standard. You can do standard too, but I mean there's like click event. There's let's see, double click, key up, key press, key down. I want to use key press. And the name of that is text pennies. And that will add that event handler into my code, we hope. And there it is. Put it in there. And I could put a region in there too if I wanted to. In fact, I probably need to fix this because that's wrong. Pound end region. I missed that. I must have deleted it accidentally. And then I can do pound region here. And then opening, closing quotes. Oop, there's a syntax error. And I can do this. Well, that didn't. Oh, there it is. Key press. Okay. Key press. Put this in here. Okay. All right, so there's that. Let's see what we're doing here. Button. That should have been. What happened to my key press? Huh. See if it'll work like this. I didn't put it in right for some reason or another. There. I don't know why I didn't put that in there. This still may not work. I may have to go back in and redo it, but we'll see. All right, so I need to determine if last number of pennies has changed. That's just a comment, that's all that is, so I'll know where I'm at. And you know, you can do your logical design that way too. Once you get ready, before you start coding, you need to know how this stuff's going to work. I mean, you can't just start guessing, because if you do, you're going to get it wrong, I guarantee you, especially with one as picky as this particular project is. In order to do that, I need to examine that modular level variable called, what was it called? Status change. So I'm going to use an if statement. If status changed. Oops. Where is it? Well, why is it not seeing it? There it is right there. Come back down here. Something funky's going on here. Equals true. That means that they're about to make a change here. Oh, fixed it. Okay. Then what we want to do is we want to run all of this code up here in button clear. Now I could copy this code down here. I could put, you know, using handles and call it that way. But I want to introduce you to something a little bit different in the book, just so you'll see it. And there's a method for these buttons. All right. So I can type button clear dot perform click. See that? What that does is it's just like somebody clicked on this. So it's going to run this code, basically. That's all it is. So that's an easy way to do it. Another way to do it, you can use the handles, or you can duplicate the code. I don't recommend you doing that because you'll have way more code than what you need. All I needed to do is fire this click event, and that would run this, okay? What else have we got? Let's see if that works. All right, save it, run it, see if I have any errors. Okay. Alrighty, so let's see. Their first one was, we did 250. Let's do 653 out of the text. And see what we get. All right, $6.53. That's right, $6.53. The rest is zero. Now watch what happens when I press a backspace or do anything in here. Wipes it all out because it has to. If I had backspaced off one of those characters, then what was displayed here would be wrong, okay? And that's what that if statement does right here. And I'm resetting that. See, after it clears, it resets it back to its initial state, which is false. That enables me to type other numbers in there. Otherwise, it would just fire every time I press the key. You don't want that to happen. Let's do 333 pennies. That should be $3.25, 55, 8 nickel, 3 pennies, 1 nickel. Oh, 25, 33. Yeah, okay, clear. Notice it put the cursor back up there. All right, let's do another one. Let's do 513. Okay, calculate. $5, $5.10, 513 cents. So that's right. Let's do one more. Let's do a big one. 2529. That's $25. So that leaves us how many pennies, 29 pennies. Remove 25 pennies, that gives us a quarter, and that's 4 pennies remaining, so that's correct. And exit. All right, so you need to really absorb what I've been telling you here. And if you need to go back through and watch it a couple times, do that. If you need to go back through the chapter, do that. But you've got to get a handle on this stuff. You can't just wait for me to put these videos out, because there's going to come a point, like I said earlier, where I'm not going to put these videos out here, or if I do, they're not going to be complete solutions. All right? Enjoy. See you in the next video.